Hello, everyone. You're watching the 2025 Emerging Trends Forecast. I'm Tiffany Nielsen, and our next guest is Pete Bernard. And Pete is the executive director of the Edge AI Foundation and an expert member of the World Economic Forum's AI Governance Alliance. Thank you for joining us, Pete. How are you today?
Very good. Thanks, Tiffany. Really excited to be here.
We're excited to have you. And AI is creating such a massive impact across most industries. And your
Mhm.
focus is on edge AI. And it was tinyML, which is turning into more edge AI. But
Mm.
can you tell our audience more about edge AI and why you feel it will be a significant trend in the year ahead?
Yeah, I mean, we refer to Edge AI as like AI in the real world, which is a little bit tongue in cheek, but it's true. It's AI that's happening where the data is created. So it's, happening in water systems and agriculture and medical equipment and manufacturing floors and retail stores and transportation. So anywhere you see AI workloads or AI code running, uh, where the data is created, we consider that edge AI. And as you mentioned, tinyML is a part of that. Neuromorphic computing is a part of that. Analog AI, physical AI. There's lots of different kind of terms and permutations, but essentially it's AI in the real world, and it's just an exploding area of expertise and business.
Thanks, Pete. And there's a lot of attention in moving the processing to the edge, but what happens if we don't move processing to the edge?
Yeah, well, I mean, the horse is a bit out of the barn on that one because the computing, there's a gravitational pull toward the edge. They say that all AI projects start in the cloud, but sort of get commercialized on the edge because people want to have more control over the data, more privacy, faster response, lower cost. And so that's why data tends to gravitate toward the edge. That being said, the cloud itself, there's lots of processing you could do on the cloud, and like the high performance training and other things like that. I think the edge is kind of uniquely qualified for some of the things I talked about, especially like low latency. Good example, like a camera for pedestrian safety. That's not something that you would send the video back up to the cloud to process to say, hey, is someone walking into the street? Or things on the manufacturing line or things in healthcare. So you really need to have that kind of high performance. Let's run AI where the data is created, and having it all in the cloud is not really a good choice.
Thanks, Pete. And can you tell us how AIoT and Gen AIoT can be performed at the edge?
Yeah, so AIoT, Edge AI. I mean, I mentioned before there's these different terms that people use to run AI models and AI workloads on edge equipment, and that equipment could be sensors. That equipment could be cameras, could be gateways with a bunch of things plugged into it, could be point of sale registers where you're doing self checkout, cameras and things like that. Um, and so AIoT, Gen AIoT, Gen Edge AI, there's all these different ways of talking about it. But one of the cool things, as you mentioned, is like running generative AI on the edge is a very hot topic. And we actually recently had a big 2 day seminar on that. We had about 900 people show up just with talks from around the world on what's happening to run transformer based models on edge equipment. We saw some of that at CES. I think we'll see a lot more next year as well. People are able to run these generative AI and transformer models in smaller and smaller footprints. They typically are not tops bound as much as memory bound. So you're seeing a lot of advancements in high performance memory subsystems on edge equipment. That's really important. You're seeing much lower power being used to run some of these AI models. You think about running generative AI in the cloud on like an NVIDIA, H100 or a Blackwell. That's using 1,000 watts or megawatt of energy or something like that to run these things, and you're talking about running it in milliwatts on the edge. And so that's kind of an exciting premise there, is that can you actually run some of these generative AI models for language, for example, and language interpretation of data on edge equipment.
Thanks, Pete. And can you
Hmm.
also tell us how Edge AI is enabling some of the advancements that we're seeing in robotics?
Yeah, robotics is like a really fascinating I want to try the right word. It's not even industry vertical, but it's a whole technical area there that's, it's got two parts to it. There's robots that are like functional robots, and they're actually around and working today in a lot of warehouses, and moving pallets around, and doing like a lot of important work that otherwise would be very difficult or dangerous to do. You could even argue that many drones are robots essentially doing visual inspection and things like that. The other part of robotics is humanoid robots, and that tends to get a lot of press. And we all as a society kind of have the fear of humanoid robots taking over. And if you go back to like the 1927 film Metropolis, which I encourage people to see, it was a silent film, and the premise was, these robots are going to take over. So even back then, 100 years ago, we had a fear of humanoid robots. And so whenever there's stories about humanoid robots, especially ones that have generative AI capabilities now, it kind of freaks people out, and it's what I would consider AI theater as opposed to AI reality. But robotics itself, that whole field, is really benefiting from higher performance AI models running on the edge. Higher performance silicon, lower power, because most of these robotic systems are battery powered. And running multiple models, running transformer models and CNN models and other models together on the same platform to accomplish certain tasks. So, all the advancements that are happening on the edge and happening in AI are really benefiting the whole robotics industry.
Thanks, Pete. And another trend that we want to highlight is energy efficient computing, which we will talk
Mm-hmm.
more about during our Green Things Summit coming up in April. But how does
Mm-hmm.
Edge AI incorporate energy efficient computing?
Yeah, well, I mean, the idea behind Edge AI is really about efficiency. Can you run AI workloads and solve a problem with not only less cost but less power, which in some cases means the same thing. Some of the semiconductor capabilities, going down to single nanometers. Look at Qualcomm Snapdragons and NXP and Olive Semiconductor and all these folks that are doing cool things on super low power chips. They're running AI workloads there that are really designed to be battery powered. So, but even if they're not battery powered, you're still consuming less power. So imagine if you're hooking up this equipment in your quick serve restaurant, or in your manufacturing facility. You want to use the least amount of power to get the job done, and keep your energy bills low, and maybe even be self-sustaining on your energy. So that's a really key aspect of Edge AI. The other part of Edge AI that's important, when we talk to like municipalities about safety and security, is deployment. So you think about deploying cameras and other Edge AI equipment out there. You don't want to have to run power cables, just like you wouldn't have to run. You don't want to run an Ethernet cable either. So can you take like a camera and post it to a post, and have it solar powered and self powered, and have it wirelessly connected, and then your deployment costs are essentially zero. Because you're not tearing up the sidewalk and you're not running cables. So it's really important to make sure we can run AI workloads on batteries and on solar power and other kind of renewables, so that we drive the deployment costs way down and give people the opportunity to deploy this technology not only on light poles, but farm fields and in the wilderness for wildlife protection and stream monitoring and all kinds of other things where there's no AC outlet, obviously.
Thanks, Pete. And you mentioned another trend that we're following, which is neuromorphic computing. So, can you tell
Mm.
us more about that and maybe provide some examples of how we might see it be used in the coming year?
Yeah, neuromorphic is a really interesting, again, subset of Edge AI, really designed about around like how the brain processes, data. And there are a number of companies that are really innovating in that space. I mean, there's like BrainChip and Inotera, IBM. Um, but neuromorphic computing really kind of mimics the brain's behavior and how it processes the data. And what that results in is very high performance execution, and also very low power. So it's not applicable to everything, but to many instances where you need very low latency processing of AI and very low power, neuromorphic computing is really fascinating. And there are chips out there, there are platforms out there. It's still early. in the business, but people are deploying it, and we have partners in our community that are doing an incredible job on it. And if you go out on the web, there's all kinds of research and talks about neuromorphic computing. I expect it to be. In fact, we just started a working group on neuromorphic computing within our foundation because there's so much interest in it.
Thanks, Pete. And we'll be covering the Internet of Things a little bit more later in today's event. But for now,
Hmm.
can you share with us your thoughts on the societal impact of IoT?
Yeah, well, I mean, I think we can see the impact of IoT and edge AI and edge computing in big and small, you know, cities and towns around the world, just in the critical infrastructure space, the ability to instrument water systems, as I mentioned, or agriculture, or any of these critical infrastructure systems to understand what's happening there and how to make them better and more efficient is has a huge impact. And the nice thing about edge AI is that it's designed to be low cost and low power. So even in a very small rural community, they can use sensors and cameras and other things to improve crop yields and improve safety and security and other things that's happening. So you don't need a giant data center to do AI. You can do it for less than $10 in a small plastic box, and you can pick up a Raspberry Pi board or an Arduino kit or any number of super low cost platforms to do it. So I think it has a real democratization effect, where not only can anyone learn it and get their hands on it and understand it, but it can be deployed at big scale and also in local communities as well. So it really is, and as it becomes more and more capable with generative AI, it's really going to open up some fascinating solutions for communities around the world.
Thanks, Pete. And that kind of leads into another trend that we're following, which is low
Mm.
power wireless. And so, Pete, I mean, how much less power are these devices using? And is there anything you'd like to share on that trend?
Well, yeah. So, edge computing and IoT are inherently connected platforms, right? They could be, locally connected to some servers, but ultimately cloud connected. And so the connectivity is a factor, and so are the ability to move workloads to these devices and do the ML ops necessary to orchestrate all this stuff. So low power connectivity is definitely an enabling technology for edge AI. To get these things connected consistently over long distances, that can also run on battery power is super complementary. So you look at like LoRaWAN, or even some of the 5G RedCap stuff, and other ways of connecting them where you're sending a little bit of data a long way and on very low power. So think about it like instead of sending as I mentioned before, the pedestrian safety example, instead of sending like a video stream over wireless, which kind of makes no sense, um, for monitoring, why not have the video stream processed locally in the camera and then just send the metadata and the events back over a very thin pipe over low power wireless back to the cloud. Same with any kind of equipment monitoring or telemetry that you would have. You're not sending the full stream of data. You're processing the data there, and then you're just sending the signals and the metadata back. And that enables you to use a much thinner pipe to go longer distances for less cost and less power. So it's sort of like I would say edge AI and low power wireless are like peanut butter and chocolate, right? They're two great things that go great together.
Peanut butter and chocolate. I guess I know what you like
Mm,
on your Sunday.
there you go.
And I'm glad that you tied in red cap, which is another trend that we plan to cover. Is there
Mm.
anything else you'd like to say about red cap for our audience that may be unfamiliar with the term?
Well, I mean, it's just when you think about connectivity, one way I think about it is there's licensed and unlicensed connectivity, right? So you've got the unlicensed, typically Wi-Fi, Bluetooth, LoRaWAN. There's spectrum allocated per region, per country for that sort of thing, and then you have licensed spectrum, right, which is typically controlled by telecommunication companies, local operators, AT&T or Vodafone or whoever. And within that license spectrum, there's standards for communicating like 5G or 6G, and and NB-IoT, and there's these various things. If you look up 3gpp.org, you can spend all day and all night reading those specs. But 5G RedCap is an attempt by licensed spectrum providers, right, like telecoms, to provide that kind of low cost, low bandwidth, low power connectivity. So it is definitely a good option to have. In some cases, I always tell people, you have to choose the right connectivity for the right solution, just like you choose the right AI for the right solution. So having that option and making it robust and cost efficient is always a good thing.
Thanks, Pete. And my last question is that since
Yes.
IoT has hit some headwinds in terms of complexity, how do you think Edge AI will avoid the same challenges? And what's different this time
Mm.
around?
Yes. So this is my one of my themes is, how do we go beyond the edge? And you know, back, maybe 20 years ago, we had this thing called embedded systems, right? These were headless devices that did something, a single function, um, typically code running on bare metal, and they weren't updatable. They weren't connected to anything, right? You built it, you shipped it, tested it, and hopefully it worked. And if it didn't work, well, you just have to replace it. So that was embedded systems. And then we had the internet coming, and so people said, well, I can connect this embedded system to the internet, and I can take this funky weird thing and I can put like a HTTPS connection to it or something like that, and eventually MQTT and other protocols. So you started having these funky, very funky things connected to a cloud, and it was hard, right? And we it was very difficult because of the heterogeneity of these devices and the fact that a lot of them were bare metal or weird Linux distros and stuff like that. All good, but very heterogeneous, very different, and trying to get them all to connect to the cloud and send data up in some coherent fashion. And then also, how do you manage them from the cloud and update firmware, for example, what we call FOTA, which is a four-letter word, by the way, FOTA. And that was IoT, and it's been hard, and I think we've all struggled with it. It's struggled to scale, it's struggled to be secure. There's a billion deployments out there, which is great, but it's taken a great effort. And so the question is, well, how does Edge AI avoid that sort of friction? And I think what's really different about Edge AI is that it's not happening from like the metal and device on up. It's happening from the cloud on down. So Edge AI is happening from AI in the cloud and using a lot of those frameworks and optimizing them and getting them to work in these edge devices. So you're talking about very similar frameworks for developing models, and you're talking about Onyx frameworks for portability, and you're talking about cloud DevOps for container-based orchestration, K8s, K3s, micro EJ, et cetera. And you're talking about ML ops. And so a lot of it is very cloud oriented. So for Edge AI to work, and this is one of the reasons why I think it is working, is that it inherits a lot of techniques and technologies that have been developed in the cloud that are very scalable, that are very standardized. If not an IEEE standard, it's certainly a standard practice and best practice for cloud DevOps and ML ops that are now reaching down to the edge. So I think that's why you're going to see Edge AI scaling a lot faster than IoT, because it's coming from the cloud on down as opposed to IoT, which came from the device on up.
Wow, Pete. I mean, you really break the information down so that it's understandable. Thank you so much for joining us today. That was a pleasure.
Sure. No, it's my pleasure. My pleasure. Thanks for having me.
All right. Well, we look forward to seeing you again on one of our future virtual events. And again, thank you so much for your time today, Pete. You really do a
Sounds good.
brilliant job at relaying this information to our audience. Thank you so
Appreciate it.
much.
All right. Take care.
Have a great day. Bye bye.